This video is going to be over function notation. Alright, what are functions? A function is a relation if for every input term there is exactly one output term. A function performs a rule on the input term and the result is the output term. The function can be thought of as a machine that changes elements from a domain into elements of a range. Now all of that is very confusing talk, so let's go over this one by one. First of all, it says a function is a relation for every input term there's exactly one output term. So if we look down here in our table, so for one input term there's one output term. If we look at our table here, we have 4 input terms and we have 4 output terms. So for every one number in the first box, there's a number in the second box. Now functions always perform a rule. They tell you what to do. So in our machine down here, you see here there's a rule and it says we're going to triple. We're going to triple the number. So our rule says we're going to triple. So what happens is you take your input term, okay, and you multiply it by 3 and you get your output term. So input times 3 equals output. That's kind of like our equation. Okay. Now our input terms have different names. It can be input, it can be domain, or it can be x for like the xy coordinate. Or it can be output, range, or y. So all of these names are the same. Input, output, or the x and the xy coordinate. We have output, range. I put input, output. I meant to put here domain. Output, range, or y. So input, domain, x, and output, range, y. These are all the same names when you're talking about input-output tables. Now if we look at our input-output table, it says that for every one number there's one output number and the rule is to triple. So if you start with 1, we're going to do our rule, which is triple. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And 4 times 3 is 12. So that is just a picture of what this looks like when you do a function. Alright, again, this slide is just telling us again that the set of coordinates or the ordered pairs in the input-output table numbers can be arranged as xy coordinates. And so again, our x is our domain and our y is our range. And so if we were writing these as xy coordinates, they would be 1, 3, 2, 6, 3, 9, and 4, 12. That's how you would write those input-output numbers as xy coordinates. Alright, in function notation, what function notation means is that you just have this fx at the beginning. That's the function notation. Instead of having y equals something, you're going to have fx equals something. Okay, our x goes here with our x numbers. So when you're doing function notation, it's fx and then you state the rule. So whatever the rule is. So in our rule, we're going to triple. Well, what are we tripling? We're tripling the x function. So we're tripling x. So our function notation would be fx 3x because we're tripling x. Now to figure out the answers, if we didn't have this input-output table already done for you, you would do f. The x input is 1, and if you input 1, you get 3. If you input 2, you get 6. If you input 3, you get 9. So all we're doing is substituting our numbers for x. So here, this is actually 3 times 1, 3 times 2, 3 times 3. Very simple. In function notation, what you do is you just replace the y. The y becomes the fx. So in our table down here, if you have the equation y equals 4x minus 2, all you do is replace the y and make it an fx. The same thing here. You're replacing that y and making an fx, and everything after the equal sign remains the same. Sometimes, though, you have different letters. Instead of x's, you might have, in this case, you have a p. So here you have a p. Now, it's okay to have a p. You just can't write fx as your notation because you don't have an x as your variable. You have a p as your variable. So in this case, this particular case, we had t equals 7 plus 3p. Instead of t, they're using g, and then they're using their p because that's the variable. So it doesn't matter what letters you use as long as it's in that type of notation with a letter, parenthesis, and another letter. So down here it says y equals 8 minus 3x. So to write this in function notation, we can still use our fx because we have an x as our variable right here, equals 8 minus 3x. b equals 5x plus 9. Because we have x as the variable, we can still use fx. So fx equals 5x plus 9. So all you do is replace the first variable with an fx. Alright, now just like when solving regular equations, it has to be set to y, so we need to set this equation to y. So remember, to solve an equation for y, you need to get y by itself. So we're going to minus 12x, get rid of it here, so we have 3y equals 18 minus 12x. Now we have to divide by 3 to get y by itself. That cancels out, so we're left with y equals 18 over 3, which can be said as 6, minus 12 over 3, which can be said as 4. You do 18 divided by 3, which is 6, and 12 divided by 3, which is 4. Remember, the fraction bar means to divide. So to set y equals 6 minus 4x to in function notation, you would just replace the y with an fx equals 6 minus 4x. Let's try another one. Why don't you try this one, and then when you're finished, you can check your answer by clicking play again. So press pause, try it, and then when you're done, go ahead and check your answer. Alright, well now that you're back, let's go ahead and solve for y. So remember, we're getting y by itself, so we're going to get rid of this 14x. So we're left with 3y equals 12 minus 14x. We need to get rid of our y, so we're going to divide by 3. So y equals 12 divided by 3 is 4. 14 divided by 3 is not even, so we can keep it as 14 over 3 for now, and then x. If you have a calculator handy, you can always turn that into a decimal or a fraction. If we're turning this into a mixed number, 3 goes into 14 4 times with 2 left over, so this is actually 2 and 2/3. So you can either leave it as 14 over 3 or change it to 2 and 2/3, or change it to a decimal, which is 4.66666666. So I'm going to just leave it as 14 over 3. So to write that in function notation, you're just going to go fx equals 4 minus 14 over 3x. Very simple. Alright, now functions can be linear or nonlinear. And a linear function refers to data or a function whose graph is a line. So when we were graphing equations in the previous lessons, it was just a straight line. That means it's linear. That means that the data goes up in equal amounts. So to be linear, the data has to be go up in equal amounts. So when you count by twos, 2, 4, 6, 8, 10, that's a linear function. If you count by fives, 5, 10, 15, 20, that's linear because every number is going up by equal amounts. If it's nonlinear, it refers to a graph that's not a line, and the data does not go up by patterns or by certain amounts. It goes up by different things. And examples of those graphs are parabolas, hyperbolas, and circles. So A linear graph will just be a line. A nonlinear graph will either be a parabola or a circle or something like that. Alright, well, let's look at a linear graph. Any equation or function that is linear will only have x raised to the first power. That's very important. So this is x raised to the first power. You have no exponents up there. So this is going to be a linear equation because it only has x to the first power. A nonlinear equation will have x raised to different powers. Quadratic is a second power. Absolute value actually has the absolute value sign. A cubic function has x raised to the third, and square root function obviously is the square root of x. So those are different looking graphs, not linear graphs. So if you see something that's not just a straight line like this, you know it's nonlinear. If it's like this, a half a circle or a V or a squiggly line or something like that, that has to be nonlinear. So here's an example of a linear function. If the pattern increases by the same value, like I said before, it is linear. So in this case, how do you get from 3 to 7? Well, you add 4. How do you get from 7 to 11? You add 4. 11 to 15, add 4. 15 to 19, add 4. So with each jump here, we are adding 4. So it's the same value, so it's linear. This is what that graph would look like, a straight line. A nonlinear function increases or decreases by different values. So let's see here. If we go from 1 to 4, you add 3. From 4 to 9, you add 5. From 9 to 16, you add 7, and so on and so on and so on. So those are different amounts, so each time you make a jump it's a different amount, so it's going to be nonlinear. And that's what that graph would look like. And in previous lessons, you remember this is a parabola. Alright, so it says which of these represents a function that is linear? Well, remember, a linear equation will only have x to no power, so just a single power, so there would be no exponents. So let's look for an equation that looks like that. Alright, now fx equals x squared plus 1. Well, it has x squared, so we know that is out. In this one, fx equals 2x cubed plus 3xy plus 1. Well, we do have an x here that is to a single power, but we also have this x, so we know that is out. Fx equals 1 over x, which could be because x has no power, and then fx equals 3x minus 1. So it's between c and d. Well, I'm going to tell you that it has to be d, okay, because when you divide an x, that does not become linear. So this is the answer. It's a regular equation with just x by itself here with no additional power. Now let's look at these graphs. It says, which of the following table of data represents a nonlinear function? So a nonlinear function means it goes up by different amounts. So we need to find the graph that goes up by a different amount. So in this particular, in A, it says y is 10, 20, 30, 40. Well, that's all going up by tens, so we know that's wrong. 2, 8, 18, 32. Well, let's find out. From 2 to 8 is 6. From 8 to 18 is 10. And from 18 to 32 is 14. Now, even though that one goes up by differing amounts, we should always check the other ones. So this is a maybe. So 3 goes up, or 3 to 8 is 5. 8 to 13 is 5, and 13 to 18 is 5. So that's the same, so that's wrong. So 1.5 to 3. Well, if you can't do that in your head, make sure you do it on a calculator by hitting 3 minus 1.5, which is 1.5. 3 to 4.5 is 1.5, and 4.5 to 6 is 1.5. So B is nonlinear because it goes up by different amounts. All right, which of these graphs represents a linear function? Remember, a linear function is a straight line, so the only one with a straight line is A. All right, now when you evaluate functions, you can use your calculator. It would be very easy to use your calculator when evaluating functions, so you need to have your calculator out. Well, what this means is if it says evaluate f4, that means the x has to be 4. So you're going to replace all the x's with 4. So this is going to become 2 4 squared plus 3 times 4 minus 1. Now, to evaluate that on your calculator, you're going to take out your OGT calculator and you're going to type in, let me see here, oh, here we go. It's over here, so let's move to the slide and I'll show you on your calculator. Alright, so I'm going to rewrite this so we can see it on this side. X equals 4, so it would be 2 4 squared plus 3 times 4 minus 1. So on your calculator, you are going to type in 2, okay, so you're going to type in 2, and then you can type in parenthesis 4 parenthesis caret, the caret symbol is the exponent symbol, caret 2 plus 3 parenthesis 4 parenthesis minus 1. Okay, so why don't you try that really quickly. So 2 parenthesis 4 parenthesis caret 2 plus 3 parenthesis 4 parenthesis minus 1. Okay, this is what it will look like on your screen, just so you make sure that you have everything correctly written down. So it would go 2 parenthesis 4 parenthesis caret 2 plus 3 parenthesis 4 parenthesis minus 1 equals, and you should get 43. Alright, now let's evaluate the same equation if it is negative, excuse me, negative 1. Alright, so if it's negative 1, it would be 2 parenthesis negative 1 squared plus 3 parenthesis negative 1 minus 1. So 2 parenthesis negative 1 squared plus 3 parenthesis negative 1 minus 1. Now on your calculator, again, you're going to follow so you're going to write 2 parenthesis negative 1 parenthesis caret 2 plus 3 parenthesis negative 1 parenthesis minus 1 equals. So go ahead and do that on your calculator. So 2 parenthesis negative 1 squared plus 3 parenthesis negative 1 minus 1. You should get negative 2. On your calculator, it should be 2 parenthesis negative 1 caret 2. Remember, your caret symbol is right here. plus 3 parenthesis negative 1 minus 1 equals. Here's your negative sign right here. Just make sure you remember that. Now hopefully that's helped you evaluate, know about linear equations, nonlinear equation, function notations, and how to evaluate. Being able to evaluate is very simple by using your calculator. So make sure you always use your calculator to either check your work or to make sure that your answer is correct. If you have any other questions or concerns, please watch the lesson again or ask your teacher.